probability and statistics portion of the year instead. So I'm going to start right on the top of this sheet. We did number 1 last week together, and we are going to do number 2. So it says to rewrite each function to determine the annual growth rate for Finn's model and for Gwen's model. Write your answer as a percentage rounded to the nearest 10. All right. So with number 2, the first portion, do we have to pull anything inside the parentheses, or we good to go? We're good. So this is already going to be growth. Why? Because it's larger than 1. So growth, and I'm going to go 1.039 minus 1, which is 0.039. I'm going to move my decimal 2 places, and I get 3.9%. Now, what's different about F of T? Excellent. You have to pull in the 12. I like it. Actually, the 112. So I have 33,131 times 1.44 raised to the 1 divided by 12 to the T. And remember that this is the only portion that is going to go in your calculator. So I go 1.44 raised to the 112. So this is 33,131 parentheses. I got like 1.03. Yeah, I guess I would round up to 1 because we're going to round it anyways. And then this is going to be an increase. So I go 1.031 minus 1. And then I'm going to move my decimal 2 places. And we get 3.1% increase. How's that, guys? Okay? And again, I know we've discussed it before, but this is what actually happens in real life if you have a credit card and you don't pay your full balance. So this is what the APR rate is computed based on. They take that rate and they break it down into a monthly rate instead. So now letter B. When does Gwen's function reach a population of 1 million? So I need to take Gwen's and set it equal to 1 million. So we want to go here, 1 million equals 48,661 times 1.039 raised to the T. All right, what is the most helpful step to take first here? What should we do? Yep, absolutely. Divide over this 48,000 number. So you're going to divide this over. Does this work out nice by chance? Well, I mean, we can go 4 decimals on this rounding. All right, so 1 million. 1, 2, 3 divided by 48,661. I got like 20.5503 equal to 1.039 to the T. All right. Again, when you get to this part, you can solve this 2 ways. Power down in front, log of both sides, or a conversion. What do you guys prefer at this point? Power down in front? Sure. And again, I think students make the least amount of mistakes doing it that way. So that's what I would suggest you do as well. So I'm going to go log of 20.5503 is equal to power down in front, log of 1.039. And then to conclude, I divide those. So we are going to go log of 20.5503 divided by the log of 1.039. And I got like, I don't know, 79.0. So that would be after 79 years, because I think this was in terms of years. Great. How's that type? We're feeling okay? Good. All right, so let's look at Newton's law of cooling again. A pizza is heated to a temperature of 400. So that represents the temperature of my object. So that is your pizza T of 0. It is taken out of the oven and it is placed in a 68-degree room. What does 68 represent? Awesome. T of A looks great. The temperature of the pizza is changing such that its decay constant is here. At what time is the temperature of the pizza 160? T of T. And therefore safe to eat. All right, so there's your formula and what everything stands for, and now you're going to start subbing in. So I am going to go 160 equals, what was that, 68? 68 plus 400 minus 68, and then e raised to the negative 0.325. Do we know t? I don't think we do. Nope, t. And now I'm going to keep going. So I am going to take the 68 and subtract it to get 92. And I'm going to also clear up in the parentheses here too. And that is 332. E raised to the negative 0.325t. All right, what should we do next? Excellent. Divide out the 332. How well does this work? 23 over 83, thank you. So 23 over 83 equals e raised to the negative 0.325t. And then how do I work with this further? What do we need to do? Natural log, excellent. So we're going to do natural log on the left-hand side here of 23 over 83. And again, on the right side, it would cancel out, resulting in just my exponent. And then the last thing I do is divide that value over, and we are good to go. So divide by negative 0.325. Divide by negative 0.325. And I get t equals how long? 3.9 minutes. Thank you. So 3.9 minutes until your pizza cools and you can eat it. Sorry, kind of making everybody hungry.
So I have a question. So instead of doing the natural log, like, can you just raise these up to what the rate is and then just like use that number? Like type that in the calculator?
Did you get the same thing?
Try it.
I was going to say, you can write it as log base e, but if you just simply raise the left side,
No.
Yeah.
Like 0.7.
yeah, I was going to say, it's not equivalent. So it's a great idea, but like you have alternatives. You don't have to use natural log. You could use log base e, but not e raised. Yep. Good question. All right, moving to your next. All right, so number 4. A parent would like to open a savings account to save up money for their children's college education. They place an initial deposit of $10,000. In the account, which has an annual interest rate of 5.2% and is compounded monthly. How long is it going to take them to save up $50,000? So this is a formula. So my formula is going to say A of T equals P, and then parentheses, you guys remember it? 1 plus, R over N raised to the N times T. That is the formula for compounded monthly, where N represents 12. So I am going to do A of T equal to principal investment of $10,000, and then 1 plus interest rate 0.052 divided by 12 raised to the 12T. Okay, so let's start plugging into this. On the left side, we're going to put 50,000, and then let's clear up that fraction. What is that value? Yeah, thank you. That's what I thought. So we're going to go 50,000 equals. Just so you have a little bit less to write. 10,000, and then parenthesis 1.00433 to the 12T. All right, and again, guys, there's always a nice place to start this. What should I do with 10,000? Yep, very good. Divide it over. So divide by 10,000, which just gives me 5, which is nice. Then you have no decimals to write finally. 5 equals 1.00433 to the 12T. And there is no need to pull in that 12, okay? Because it's not asking you to express it as a rate. It's just looking for you to solve, so don't worry with that part. So now I'm going to do power down in front and then log of both sides again. Or you can convert it, makes no difference. So log of 5 is equal to power down in front and then log of 1.00433. I'm going to divide by the log value, and then I'm going to divide by the 12. So divide by log 1.00433 and divided by log of 1.00433 equal to 12T. Oh, kind of calculation work. So log of 5 divided by the log of that decimal gets me like 372. Point like 2129. And divide by 12. Divide by 12, where T is represented according to this formula as time in years. So how many years is this going to take? Yeah, so is that really going to be helpful for college? Yeah, no. Unless they go to college when they're 50, then yeah, that probably wouldn't be too helpful. So T equals like 31 years. It's okay. I mean, the expectation's kind of lofty here. You're asking them to multiply their money by a factor of 5. Okay. So 31 years altogether. All right. So number 5, nice science application. So titanium-44 is a radioactive isotope such that every 43 years. I'm going to stop. What do we do with every 43 years? Wonderful. And all these questions too are old Regents questions. This is usually a very heavily hit unit. I know you guys aren't responsible for Regents, but that's where all of these came from. And its mass decreases by half. So I'm going to go 1 minus 0.50. For a sample of titanium-44 with an initial mass of 120, write a function. I'm going to do this. P of T for titanium equal to 120 multiplied by 0.5 raised to the t divided by 43. Now use your equation to figure out the mass between your 0 and 15. So all you have to do is plug them in. So let's do t of 0 equal to 120 times 0.5 raised to the 0 over 43. What's anything to the 0? 1. Yep. So this answer is just, yep. Perfect. Now I go over and I'm going to do year 15. This one you have to calculate. 120 times 0.5 raised to the 15 over 43. We can go nearest tenth of a gram. Thank you, 94.2. And that would be grams. Just so we make your science teachers happy, right? I know you lose a lot of points if you don't put units on science questions, right? Yes. All right. So 6, find the percent change. What does this involve? Yeah, yep, the stuff in the parentheses. So this becomes a 0.75 to the negative x. All right, we actually don't want to leave it like this. So I want to pull that negative 1 inside. So I'm going to go 100 times 0.75 to the negative 1 to the just plain x. And then we can express the rate. So this gives me really 100 times 1.333 repeating to the x. So this is going to be exponential growth. You take the 1.3 number minus 1, move your decimal 2 places, and I get 33.3% growth. We feeling comfortable doing those? Perfect. All right, now you're going to do a financial comparison. So Seth's parents gave him $3,000 for his 16th birthday. He is considering 2 investment options. Option A is going to pay him 4.2% interest compounded annually. Option B is going to pay 4.6% interest compounded quarterly. Write a function for option A and option B. So let's do that. So for option A, now even though it says compounded, it's annual. What's annual mean I would use? Just a 1. So because I only use a 1, dividing by 1 is really kind of unnecessary. So I'm going to just write your simple interest formula instead. So I'm going to go 3,000. And I'm going to go instead 1 plus, and then 4.2% interest would be 0.042 raised to the n first. So this function is 3,000 times 1.042 to the n. And it says after what, 6 years? So now sub that in. So 3,000 times 1.042 to the 6th. All right, what do we get from this? Raised to the 6th. All right, I got $3,839.97. Now we're going to write a function for option B. So B equals $3,000 still, but this one's compounded quarterly. So I have to go 1 plus 0.046, and quarterly I'm going to use 4. Raised to the 4n first. Because it first said you have to write a formula. So if I continue, this is b equals 3,000. What's this value become here? 0.046 divided by 4. Thank you. Yep, that's correct. Okay, so that's your answer for part A. Now for part B, I have to figure out to the 6th power. So B equals 3,000 times 1.115 to the 4 times 6. All right, I'm going to type all of that in. I get an answer of like $3,947.32. So the question tells you, determine how much more money option B will earn him than option A. All I have to do is subtract those out. What do we get? 47.32 minus 0.97. The difference was equal to, all right, $107.35. Okay. Now, algebraically determine to the nearest tenth of a year how long it would take for option B to double Seth's initial investment. So then we're going to keep going and we're going to solve. So if he started with 3,000, what must I set this equal to? Exactly, good. This is the last part. This, as far as the Regents question goes, this was worth 4 points when this was given. Okay, so it is a substantial amount of work. So I'm going to take here 6,000 equals. This is like part C. 3,000. And then I'm going to go 1.0115 raised to the 4n. Immediately divide your 3,000 over, which gives me 2. And I say 2 equals 1.0115 to the 4n. And then if you prefer, power it out in front, log of both sides. So the log of 2 is equal to 4n, and then log of 1.0115, and then I'm going to divide by the log and then divide by the 4. So divide by your log, and then lastly divide by your 4. I know I'm going to run out of space here a little bit. All right, so the log of 2 divided by the log, 1.0115. I got like 60.6196 equal to 4 times n. So divide by 4. Divide by 4, and we get n equals what? 15.2. Perfect. So 15.2 years. Because n represents your time in years in this capacity. Okay. How are we feeling with the applications, guys? Pretty good? Awesome. So change here. There's one more review sheet that I gave you. And on it, it actually says test. I told you it's not a test. Don't panic. So you're going to find this sheet. And we'll skip around and we'll do some of these. How about that? We will do, someone pick for me 1 or 2. 1. So number 1 says population of a town increases according to the function. First, what is the yearly percent change? So that, when the question is worded that way, is when we need to pull that -2 inside. So that's my first answer. So I'm going to go 25,275 times 0.93 raised to the -2 to the t. This goes in the calculator, just this part. All right, what do we get from this? Thank you. 1.15, yep, he's right, 62. So this is growth again. So 1.1562 minus 1.1562. And then again, you're going to move your decimal 2 places. And that gives me an answer of like what, 15.62%. Then it asks, in what year will my population exceed 100,000? So lastly, I take my formula and I set it equal to 100,000. So 100,000. And hopefully the more of these you see, the better you feel like you're getting with them. This is 275 raised to the 0.93 to the -2t. And again, I'm using the original so that we don't have any particular rounding error in this question. That's why you actually don't really want to use the one that we did on the left. So I'm going to take this value, divide it over. So 25,275 and divide by 25,275. Does this work nice? No. Well, let's get it a little bit, let's round this decimal off then. Just because these tend to be difficult to, write. So 3.9565 will go. Equals 0.93 raised to the -2t. Again, if the power down in front log of both sides is working for you, keep using that strategy. I'm going to go log of 3.9565 equal to power down in front log of 0.93. Divide it over and divide by -2 and you're done. I'm going to divide by the log of 0.93. Divide by the log of 0.93. And then my answer gets divided by -2. So 3.9565 divided by log of 0.93. And then that answer divided by -2. Just get like 9.476. Yeah. Perfect. So T, 9.476. What did we say? In what year? So that's how many years have passed. When did we start this? 2015. Yep, so plus 2015 will occur sometime during the year 2024. I'm going to say during 2024. About halfway through that year. Okay. How do we feel population increase, decrease? Pretty good? Okay. So skipping around a little bit. Let's do, where is it? I am looking for, actually, I think there's a lasagna question out here somewhere. The last one. I wanted to do another cooling question. All right, so over to 7. And then if you want to go back and do any of these, you're more than welcome to. But I think you're probably feeling good and confident at this point. So a dish of lasagna is baked to a temperature of 375. What does 375 represent in the formula? Yep, very good. T of the object. It's placed into a kitchen that is 72 degrees. So what does that represent? Q&A. 3 minutes is just T. What else do we know? Lasagna is 365, so that is T of T. And then what's the temperature of the lasagna going to be after 15 minutes? We'll get that in a second. So what's unknown in this capacity is your K value. That's what we have to solve for first. So I'm given here that 365 equals, I'm going to start with my T of A, which was 72 plus 375 minus 72 e raised to the negative k times 3. So you have to find your decay constant first. Then you sub into the second part. So 365 minus 72 is 293. Inside your parentheses, 375 minus 72 is 303. E raised to negative 3k. Divided by 303, and then you're going to do natural log of both sides. All right, so I have 293 divided by 303. 0.966. Well, I guess that would round up, wouldn't it? I'm going to just do this. It's close enough. E raised to the negative 3k. Natural log of 0.9669 equals negative 3k. And then divide by negative 3. Let's just go like at least 3 decimals on this. Let's see how it works first, and then we'll make that decision. So natural log of that value divided by negative 3. So how about this? 0.011. That's sufficient. All right, so we need to figure out, that's my first answer. So K equals 0.011. And then what's going to be the temperature of the lasagna in 15 minutes? So now T of T is unknown. So part B last. T of T. Yeah, we could put the 15 in there. I'm not just leaving it all off, but yep, you're right. So T after 15 minutes equals 72 plus 303 e to the negative 0.011 after 15 minutes. All right, so you're going to actually type this entire thing in the calculator. We know that whole side. Negative 0.011 times 15. Did everyone get like 328.9? Perfect. So the temperature of my lasagna after 15 minutes have passed is equal to 328.9 degrees Fahrenheit. And that is your last answer here. So 328.9 degrees Fahrenheit. All right. So how is everyone feeling with the applications? You guys think you got a good grasp on those? Yeah, we've done a lot of review with that. So what I would like you to do for tomorrow is, can you bring with you that probability packet that I handed you last week? And your assignments for this week and the plan for that matter. Let's see if I can pull this up now and see if this will work. All right, it looks like it does now. So we finished a review. Tomorrow we're going to see how far we get with probability. We're definitely going to do your first 2 lessons. I don't know if we'll be able to get to the 3rd or not, so that's a little bit subject to change. And then Wednesday will be your time to get started on your assignments. You have a review to do online, a quiz, and then you'll have 2 problem sets, if not 3. Okay? Questions on anything, guys? And it's the end of marking period 3 this week too. You've got a couple minutes if you need to get yourself organized.